system. Stars are famous. Stars are famous because they glow, they generate light. As they generate light, they are visible from the earlier time of human knowledge. We always look at them and we see them in the sky. And this is a light object. It can generate its own light. Stars are capable of generating its light by the process of nuclear fusion. Uh, our sun is a star, not a very big one actually, compared to other one, is not a big object, but, but for us, it's very big. The sun is a star of medium size. It generates a lot of energy because of the fusion of hydrogen nuclei, and this radiates energy in the infrared, visible, and ultraviolet region. So stars generate their energy by nuclear fusion. So sun is a star. Look at this, H21 plus H21 gives you helium. This is called nuclear fusion. In our previous chapter, nuclear physics, we have discussed that what is fusion. What happens in fusion? Smaller nuclei, lighter nuclei join together to form a heavier nucleus. Stars are all in the sky and they all are light objects. So we have some important points for them. Number one, some important points. Galaxies are each made up of many billions of stars, and the sun is a star in the galaxy known as the Milky Way. Some of these points we already know, but what this chapter is doing, it is collecting all the old knowledge which you already have in the science book of class 8th, but it also includes the new knowledge. So it's a new chapter, and they are consolidating the concept. So the astronomical distances are very long. So you do not use a normal distance unit. We use light year. What is light year? Light year is the distance traveled in vacuum by light in 1 year. So light is so fast, but when light travels for 1 year, if light travels for 1 year, it will travel some distance, and that distance is called star. Oh, sorry, that distance is called light year. So there are some, these are some important points about stars. So you have to copy these points. You have to copy these points. I'm just coming, and you please let me know once you have copied it. Now this is a little derivation. How much distance light travel in 1 year? Light can travel a huge distance because light is traveling at a very high speed. This is a simple calculation to show that how much distance light will travel in 1 year. So you have to copy this. Now, give the heading life cycle of a star. This is an important topic. This is an important topic. Mark it important and life cycle of a star. Now, how a star begin its life? The first point to there, a star is formed from interstellar clouds of gas. In simple terms, there are some regions in a space, where big rocks are there, and these rocks come together due to the gravitational force. And when they come closer to each other due to gravity, the force, look at this gravity, the two big rocks like objects are there. When they come close to each other due to the compression, hydrogen nuclei fuse. Hydrogen nuclei fuse and energy is released. This is how a star begin its life career. First point, that star is actually a composition of clouds of gases, dust, which contain hydrogen. Why hydrogen? Actually, hydrogen is needed because hydrogen nuclei has to be fused. Hydrogen nuclei are the source of energy. Now the cycle start with our initial initial word protostar. First of all, a protostar is formed, and it is an initial stage, but it is not ready for fusion. So first we give the heading life cycle of a star, and we copy the initial title, that a star is formed from interstellar cloud of gas and dust. We have to copy this. Now, first of all, a protostar is formed. It is the baby star. It is the birth time of the star, but it is not able to start fusion. Initially, it is not ready for fusion. It's a little glow in it. Now you have to copy this screen. Now, what is a protostar? Basically, it's a cloud and it is squeezing, expanding, and the gravitational force is very strong gradually. And then a time will come when fusion can start. A time will come when fusion can start. So it becomes a stable star when the inward force of gravitational force is equal to the outward force. When the two forces come equal to each other, when the two forces come equal to each other, the star is able to be stabilized. So you have to copy this screen. Let me know once you have copied it. Uh, have you people copied this? So now this is my next concept. This is how the life cycle of a star begin. Life cycle of a star begin. So after going through the life cycle, a time will come when a star begins to die. So life cycle of a star begins. This is how a star begins its life. Gradually, the time passes and a star is now getting old. Its fuel finishing, and the star eventually begins the death cycle. Star begins enter its life cycle termination. So this is my next concept. You have to copy this. Now, how this cycle begins? The cycle begins that most stars expand when they are about to die. They begin to expand, and this is called red giant. More massive stars can even expand to form red supergiants when most of the hydrogen in the center of the star has been converted to helium. The red giant from a less massive star becomes a planetary nebula. You can see in the figure. So some stars, there are two ways. The big stars, very huge stars, they convert into supergiants. Normal stars, they expand and they become red giant star. Now, planetary nebula, the red giant from a less massive star form a planetary nebula. It's a mixture of gas and dust. Then, when a star reach the end of their lifetime, they are torn apart by a massive explosion, which is called supernova. And the red supergiant explode as a supernova. So the convert either into a neutron star, another very big player in space, or a very famous name, black hole. A lot of movies have been made on this black hole. So when a star is going to die, when a star is going to die, the star, all hydrogen nuclei get fused, star expands. Less massive star become a red giant. Massive stars become red supergiant. Planetary nebula with the white dwarf and other ones have two options. Either they convert into a nebula or neutron star or black hole. Black hole is very famous with passage of time, and neutron star is not that much famous, but it is there. It's a very big entity, huge entity. This is called end game, end cycle. So now you have to copy this screen. Copy this sequence. This is how a star is going towards its death. Now, a neutron star. Neutron star is the collapsed core of a massive supergiant star. It is a very mysterious object, one of the most powerful players in the universe, like black hole. Black hole itself is a region of space-time. It has so much high gravity that nothing can escape, even the light cannot escape. Now science is claiming the discovery of white hole also, but not in our course. So these are two massive players. So the nebula from a supernova may form new stars with the orbiting planets. So when the nebula is formed, just like our sun might be a nebula, so it can then lead to a process. So it can go under this process. This is a sequence. I will post it, and you people have to learn it, that how a star is made. Nebula, protostar, main sequence, then it's a two-branch process. This is called the life cycle. Then what you people had called, copied, it is called the death cycle. So this is the life cycle of a star. So you have to be careful. This is called the end cycle. This is called the end cycle. And if you see this one, this is our neutron star. Now you have to copy the definition of neutron star. This is called black hole. You have to copy this. So we keep it up to here, and we will inshallah continue in our next class. Thank you.